School of Startup. So I can see that many of you have a familiar face for me. But for those who are the first time here, the School of Startup is the 3-week series of workshop, which is cover the business, design, and tech topic. So we have the last 2 weeks with another topic. So this week we will focusing on the tech, which is provide you more hands-on and skill relating to technology and help you to build up, start your business and startup career. And the School of Startup is hosted here in the Shortcut Lab, and we are non-profit organization under the Startup Founder, and we are sister organization of Slush, Junctions, Wave Venue, Ringsing North, and Maria 01. So I won't take much time of you, but let's have few logistic things. We have 2 restrooms available here, one right in your left, the first door, and another one is down on the hall in the corner. And we appreciate a lot if you can fill our feedback form in the end and give it us. Please give to those who have the shortcut t-shirt. And if you have any ask for help, you can ask us as well. And we will have the live stream today and have the picture. Does anyone don't want to appear on the picture? So no, I see that everyone willing to be promoted. So okay, so welcome our speaker today, Jessica Pitherin from Chaos Architect.
Yes.
Yeah.
Hi. All right, so here's the long description of the workshop, because I realized on the web, on the schedule, it was condensed down to one tiny little sentence, and I didn't feel like it completely captured everything I was going to talk about. So if this is not what you are on board for tonight, bye. Have a good evening. No. But yeah, so I am going to be talking about, I have data. Now what do I do with it? So specifically looking at okay, what do I do, but also what are the tools and places I can go to learn more about how to do this that are free on the internet. So first things first, who are you guys? So are you guys, whoop, nope, gonna get way too far ahead here, crap. No, I want to know who you guys are. So, how many of you guys are business owners? Got a couple? Okay. How many of you are members of startups? Yeah. How many of you have taken a statistics class at some point in your life? Even if it was a million years ago. Okay, thank God. Okay, we have some common ground. Okay. So how many of you work with data on a daily basis? How many of you work with data maybe every now and then? Anybody never work with data ever? Okay, cool. So then of those people that work with data, how many of you would consider yourself just a total data analytics noob? I work with data, but I don't know what the hell I'm doing. Okay, cool. Thank you for your honesty. I'm glad you're here. Is there anyone here who just feels like they're a pro with data analytics? Okay, cool. So everyone else is kind of somewhere in the middle then. So then who am I? As you already saw this screen. My name is Jessica Pitherin. I am a data scientist and the head of AI development with Chaos Architects. We are a data and AI company that is looking to pull meaning out of messy real-world data to be able to give decision makers tools to be able to make better decisions, specifically when it comes to how we build our cities. So on a personal level, I love pulling meaning out of data, and I like finding the patterns and insights in messy, real-world, chaotic data. I've studied applied mathematics and statistics as an undergrad, and then I've worked within the field of data science for a while, and then also I'm such a nerd that I just was like, I need to know more. And so I've continued exploring data analytics and machine learning and AI and statistics and all those fun things through open source sources like MOOCs, massive open online courses. So what I want to give to you guys today is to like impart some of my excitement about how much I love this stuff, but then also where can you go next, because you're going to be so excited about this when you leave that you're just like, I have to do this right now. So at least that's my goal. All right. Man, this is super tiny, so I'll read it out loud for you guys. Well, can you in the back, can you read the screen a little bit? Okay. So this goes back to my Communications 101 class, my first semester of undergraduate. And my professor was like, when you do a presentation, you tell them what you're going to tell them. Then you tell them. And then at the end, you tell them what you just told them. So that way they remember. So this is what I'm going to tell you. We're going to go over some buzzwords today. So we're going to be talking about, those are going to cover types of data, data storage, types of analytics, and some other stuff thrown in there too. Then the second section is we're going to be walking through what do you do when you you want to analyze something, how do you actually do it? And so we're going to go through that from the perspective of the scientific method, which if you remember back to like high school, maybe you probably heard that once before. So we're going to go through that and use that kind of as our roadmap for how we go through an analytics project. And then at the end, I'm going to give you guys some resources, some of my personal favorite resources for learning more about this stuff online. So, okay. So one last thing before we jump in. I want you guys to take a moment to think, what is a business need or a question that you want to answer with analytics, potentially, from your business? Because a lot of you, you're like, you own your own business, you're part of a company that's new and starting and doing cool things, or for whatever reason, you decided you wanted to show up here today and learn some stuff about analytics. So think for a second, write down on a piece of paper, on your laptop notes, real quick, of one case that you could use some insight from data. And raise your hand when you've got it. All right, the rest of you can kind of just let that simmer on the back burner of your head for as we're kind of going through this stuff. So then the next thing, as you're still thinking about that, or maybe as you've got a clear picture in your head what you want out of analytics right now, as we're going through this next section, which is going to be buzzwords, write down the most relevant keywords that you find. Let me make sure I can actually spell this correctly. Yes. So the words that you see that we're going to be discussing, write down ones that like catch your eye, seem interesting, seem relevant to what your business need is, or a question, or just your curiosity. And then we will have a chance to share them at the break. All right. Buzzwords. All right. First off, what is data? So we all have something like a unified definition to work from for the next 2 hours. Okay, data is a distinct pieces of information, usually formatted in a specific way. Metadata, so that's your data, that's your pieces of information. Metadata is the information about the data about the data. It gives you the context. So it says, maybe I've got a data set that's just like date, error message. Date, pass, fail. What does that mean? Do we know what that's actually referring to? Do we know what passed, what failed? Do we know what errored? Do we know anything about that? So that metadata is what tells us, gives us reference for how this data can be used and what is the meaning we could potentially pull out of it. All right. So an example, this is from Helsinki Region InfoShare. It's actually one of the open data sources here in Helsinki. So you can go and look this up and play with this later if you want to. So we have data, which is this portion here. And we've got some column headers, and we've got some rows with data in it. And then outside, before you click in to download the Excel file, it gives you some of this stuff. It says the title of this data set is Population Projection of Vantaa by Age and Gender 2018 to 2045. Then it gives you a quick description. This data set provides the population projection of Vantaa until the year 2045. The statistics are available by age and gender. So it gives you an idea what can I actually find in this thing. Okay. So yeah, just another picture of that same thing. Here's an actual link up here, so when you get the slides later and you want to play with it, you can go there. And so here, this little thing right here, that's the Excel file. That's the actual data. But then all of this down here is the metadata about it. All right. So we have data. It can be in tons of different formats. Absolutely crazy how many formats data can be in. But kind of the two basic buckets or categories for what data can appear in is structured or unstructured. So structured is information that's very well organized and easily searchable. This can be something like an Excel file, or it can be something like a JSON data structure tree. And then we've got unstructured data, and these are things that are like, may just be a giant bucket that we've just dumped data into over the years. It may be something that's just has like a logical way that it's been put together, like a tweet. Like a tweet's got your timestamp, who the tweeter was, and then a massive text. And so the real, like, a huge chunk of the information that we actually want to know, potentially when we're analyzing like tweets for like sentiment analysis or like location reference or like hashtag references or something like that, that comes from that text-heavy piece. And that's not as easily read and analyzed by machines. It is, they definitely can do it, but it's not as quick and easy for them. So unstructured data, structured data. Yeah, I've got some more kind of examples of unstructured data types. We've got text files and documents, servers, websites, application logs. So that's kind of like that date time, error message, date time, this person logged in this time. Sensor data, so things like IoT, Internet of Things. So temperature reading in your smart home that comes to your phone. The cameras on the parking garages that count how many cars are coming in, those types of things. Images, video files, audio files, emails, and then I already mentioned tweets, so social media data. All right, big data. This is a thing everyone talks about, everyone wants to get a piece of this because it is just like the most exciting thing in this century, apparently. And if I can find my mouse. Go.
Is all metadata data to some other metadata? This context keeps.
Yeah, potentially.
Yeah.
So
where's the ceiling to what's meta, or is it just defined by the project?
It's defined by the project because there's things that, for instance, some of this data that you'll see on open data sources is actually summaries of the raw data. So it'll be things like the average rainfall for the year of 2018 in Helsinki was this much. The average rainfall for the next year was this much. And so those are, in a way, an abstraction of the raw data, which could also be metadata. And sometimes the metadata is more interesting to us because we're like, okay, maybe what we want to know is on this Helsinki region InfoShare, how many data sets are about population? And so maybe that's the actual information that we're wanting to analyze, and it's not actually what's in the data sets in there. So welcome to the world of analytics. Everything is everything. And all the borders are fuzzy, and reality exists, but it's very confusing.
Just like life.
Exactly, just like life. So big data, this is such a hard term to define. And as I was researching this talk, and actually as I was looking at becoming a data scientist that dealt with big data years ago, I was like, what the heck is big data? Where is the line of where is it big and where is it not big? And is there a switch that flips that says, all right, you have now entered the big data zone? Or, what is it? So really, what it means is data of a certain size that you cannot manage or maintain or process easily. So it's more of a question of your approach and the resources that you have than the number of gigabytes or number of rows and columns. And so kind of an example of this is if you're a biologist studying the social behavior of naked mole rats, and you built this custom deluxe habitat, and you have 9 megabytes of tracking information gathered over the course of a couple months. For you, with your resources as a researcher who doesn't normally deal with huge amounts of data, that can be a lot of data to deal with, especially if it's very dense data. And if it's all text files, 9 megabytes of text is that's a good chunk. But then also at the other end of the spectrum, if you're Google and you're used to just gobbling up petabytes like candy, you consider it fairly routine to test your new algorithms by running it on a large portion of the web, then your definition of what really is big is going to be different. But yeah, so the line between big data and not big data is a sliding scale, and you will hear conflicting definitions of it because it is a sliding scale. And it's a buzzword, which means everyone has decided they have a definition for it, and it's not necessarily the same as everyone else's. So another thing this is one that I've heard more recently, so I don't know if I just hadn't stumbled upon it yet or if it's kind of more new on the scene, but this concept of thick data. So big data is just, I have this huge thing and I don't know what to do with it. But it may be filled with lots of good, important information, or it may be a lot of information about one thing. So thick data is data that's focused on understanding the story behind the numbers. And so it's not just thick because it's wide instead of deep. It's because it's rich. It's looking at the story. It's looking also at specifically the human story behind the numbers. And so so it's usually smaller data sets that are gathered through surveys, focus groups, interviews, questionnaires, videos, something that will tell you, okay, this person who is a customer of mine, they are one line of data in my database. And or maybe there are a couple more lines of data, and they have their tendencies and the way that they shop on my website, perhaps. And I know that about them, but I don't know why they decided to purchase that one thing. Did they purchase a baby onesie because they're pregnant? Did they purchase a baby onesie because their friend is pregnant and they're going to a baby shower? Did they purchase it to give to charity? I don't know why. All I know is that they purchased it. And so thick data helps to give more meaning to the holes that can be left in big data. All right, database. Collection of information organized so that it is easily accessed, managed, and updated. This is a very vague definition, and that is because there are so many different ways that you can organize your data. And we are going to talk about that. So the two kind of main categories, we have relational databases, which are SQL, structured query language, and then we have NoSQL databases, which we'll get to on the next slide. So for relational databases, these are the ones that look like Excel spreadsheets. So it's kind of an easier way in some thought processes to transfer from I have data in Excel to I have data in a database, because visually it looks similar. Couple things to note about SQL databases is they're organized, well, we talked organized tables with rows and columns. Each row in a table has to have a unique key or and that key can either be just like one row, or sorry, one cell, or it can be a combination of a couple cells within a row, but it's something that sets that row apart as being individual, unique, so you can search for it later. And then tables, so if you have enough data to actually want a database, then you're probably going to have more data than will fit in just one table. And so instead of having one massive table with everything you can imagine, it's much easier for computers and for humans too to be able to sort through and access their data if it's in smaller chunks. And so for relational databases, we split data into smaller chunks or tables, and then we connect those tables via matching keys. So here's one that's like, okay, they have an order. This order included 5 items. So then the order ID goes down to here. Okay, we know that this order was conducted by this customer at this time for this much money. For this customer ID, which isn't actually in this table, it would be up here. Then we would know, okay, the name of the customer and the email address that we can send them their receipt. But yeah, and then at the bottom there's some examples of kind of popular SQL database styles or providers. All right. Non-relational databases. These are very interesting to me. I just started playing with these actually, because I come from much more of a background of, okay, we have rows and columns. I was doing SQL administration, SQL database administration for a while. So this is really interesting to me. It's kind of like the Wild West, no man's land when it comes to data, or at least to me, who's very used to, we have our like nice, neat rows and columns, and we don't go out of that. But there's some really nice uses to these. So instead of storing data in your rows and columns, each item is stored individually with a unique key. So it still has a unique key, but it's just not necessarily referring to a row. So they're a much more flexible approach to storing data because they can either be unstructured or semi-structured, which makes it really nice for especially like web application databases where you are like you are potentially changing as you go over time what types of data you're collecting about, say, each of your customers or something. And so it's very flexible that way to be able to update it on the fly, and you don't have to go back and back populate dummy values in other places. But yeah, so we have kind of 4 different categories for NoSQL databases. They're, like I said, it's kind of the Wild West, and so categories is kind of a loose term for that. But it's killing me. So the first one is key value. And so this is, you've got a unique key, and I have a value. And I find the value by looking up the unique key. The next one, wide column store, is the most similar to relational databases and like the way it looks visually, because you've got your key value column, and then you've got rows, but instead of having a value for every single field in your table, you would have like some of your columns would be missing for some rows. So that's not really something, it's a little bit difficult to visualize, but it's similar, but each row can have a variable number of columns. The next one, document, is it's a unique key and then a semi-structured format, so kind of like a JSON file, if you guys have played with those at all, where it's got like, yeah, you guys can look it up later if you don't know what it is. We have more things to talk about today. And then a graph, which is, well, it's kind of, I mean, it's right there. It's like, okay, I have a starting point, and then this piece connects to this over here, and this connects over to here. So it's kind of like a web of data or a network of data. All right, if you think those are fun, go ahead and look them up more later. I have included on the slides, I didn't mention earlier, included on the notes for the slides, like there are links to additional sources of information if you guys want to like look into it more. And then I also have more things at the end. But yeah, so data, cool. We know what data is. We know how it's stored. So now let's talk about what do we do with this data. So analytics. Analytics, at its basic, most basic, is information resulting from systematic analysis of data. So most basic. So that doesn't even have to be statistics. It's just like, oh, looking at this board, there's some green and some blue on it. I just analyzed it. So yeah, most basic level. Statistics specifically is a branch of mathematics and science that's dealing with the collecting and studying of numbers that give information about particular situations or events. And it's been around for a very long time, and it's a tool that we love and use anyways. So let's go ahead and get on to kind of some more deeper stuff about this. Where's my next one? Okay, so types of analytics or statistics, just to kind of categorize them. Specifically, we've got descriptive, predictive, and prescriptive. So descriptive is what has happened in the past. What do we know about what has already happened, or what has come to pass? Predictive is I want to know into the future. I want to look into my crystal ball and figure out, okay, in 5 years, the property values in this neighborhood are going to be X amount of euros. Prescriptive, like prescription you get from your doctor, this is, I'm specifically analyzing this because I want to know how to make a decision. So what should we do? All right. So now let's get into data science. The way I think about data science is statistics and computer programming had a baby, and it's big, and it just does big things. So specifically, it's a little bit more than that. But if you've read anything about data science on the internet, it tends to be like, oh, the data science unicorn is someone who's like awesome at computer science and IT, and is awesome at math and statistics, and knows things about business. And yes, but I mean, you can be a little bit more, you don't have to be like awesome at every single thing on this chart to have fun with data science and to do some cool things with it. So, but in general, it is a cross-section of those three areas. All right. So another thing that comes up a lot when you look on the internet about data is data mining. And now we're getting into kind of some murky water of there are a lot of buzzwords and tools for pulling information out of data that are related to each other, that are like descended from each other, that share the same types of tools. And so some of these definitions are going to start overlapping, and that's okay, just so you are aware. So data mining is the process of sorting through large data sets to identify patterns and establish relationships to solve problems through data analysis. So this can include statistics. This can include machine learning. This can include just querying to find totals of things, like how many customers do I even have in this like mound of things, or specifically how many repeat customers do I have. And so, yeah, so data mining, imagine a mountain of data, and you're trying to get into it to pull out information that's useful to you. All right, so before we get into machine learning, I want to give some background. Machine learning comes out of artificial intelligence, so we're going to talk about that for a second. So, artificial intelligence, at its most biggest umbrella term, means any task performed by a program or a machine that if a human carried out the same activity, we would say the human had to apply intelligence to accomplish the task. So interpret that as you will. But some of the things that kind of could fall under that would be planning, learning, reasoning, solving problems, representing knowledge, perceiving, moving, manipulating objects. So that's AI. So there's two types of AI. The first one is general AI. And this is the one that pretty much like any person on the street is going to be they're going to know this. The idea of general AI is a flexible form of intelligence capable of learning how to carry out vastly different tasks or to reason about a wide variety of topics based on its accumulated experience. So what all that means is God made man in his image. Man made robot in his image. So this is the idea of all of these examples of like intelligent, sentient robots that we see in our sci-fi. That's kind of more where that's going. Can you guys name any more? Like AI in like science fiction? Or what's your favorite one? Anybody want to volunteer? I know there's got to be some geeks out there.
I think Harley is not represented.
Oh, yeah. That one's from, which one is that one from?
2001 Space Odyssey.
Yes.
Wally?
Oh, no, I didn't get Wally, but I got his friend, Eva.
Ex Machina.
Oh, yeah, that's a good one. Anyone else? Huh? Oh, yeah. Oh, man, how did I miss that one? That's so popular right now. All right. Another thing I wanted to point out specifically is this with Jarvis. Jarvis is still an AI, even though, at least at this point in the series, he didn't have a physical form. So AI isn't just connected to physical robots. It can also, it's just any system that can like think through and reason through things. All right. That was a fun slide. And now you guys are all going to have to, yeah?
Would all these new voice assistants like Google Home and Alexa, are they kind of these large companies' initial take on general purpose AI, because they are trying to be quite broad and across stuff?
You actually had the perfect lead into my next slide, so thank you.
I've been fooling around with Google Home at a friend's place recently.
Yeah.
It's pretty interesting what it can't do.
What it can't do?
What it can't do.
And that's where the difference lies, is that even on these really smart systems like Siri, or, I mean, I could have put up like a million, there's Google Home, there's Alexa, those are the big ones right now. I'm sure there's others. Someone was telling me the other week about like Annie or something like that, that's like an AI, huh? Maybe, or no, it was like a personal assistant that sorts your emails, and it's like a personal secretary AI. Or maybe it's Amy. I don't remember. But, so yeah, that's us trying to get there, but we're not quite there yet because they do have some very severe limitations. They might be very cleverly programmed in, like, I can't remember what the current Siri one was, but like when she first came out, there was like, ask Siri this, and it's not something she can like really actually answer, but they pre-programmed in some really like silly answers, and so everyone's like, that's amazing, even though it's like they're asking her to do something she can't do. But yeah, so these narrow AIs are the ones we see around all the time, everywhere. So we've got Siri or Alexa or whatever, I can't remember what the Google one is named, that answer your questions, they take down notes for you, they can schedule appointments in your calendar, they can do all kinds of things. Then we've also got like things like physical robots like Roombas. They're like my favorite things ever. I hope to get one someday because just like the image, like the videos of all of them like trying to learn a new floor plan, like you move your chair like a foot to the left, or like, sorry, I'm American, so I think in feet and not like meters. And then they're just like completely lost. So they're learning, they're using AI to learn your home layout. Discover Weekly from Spotify is like, okay, you've listened to these things. I think you want to listen to these things. Facebook's facial recognition, so you don't even have to look up your friends anymore. You're just like, yep, that's them, that's them, that's them. Oh, wait, that one's a little weird. Scroll down. Okay, no, that's them. And then the last one, this one, I love Google Maps. It's like my favorite thing ever. I can read an actual map to like put that out there. I've done it. I learned that skill, and now I've moved on to the next era of technological enlightenment, and I love Google Maps. But one thing that it does is it's not super AI based quite yet. It's getting there. They're putting in more features. But one thing that I really like about it is, especially when I'm driving in a city with a lot of traffic, it will tell me like, okay, this area is congested. How about you go this way instead? So things like that. Do you guys have any, like, what's your favorite narrow AI that you use like every day?
Google Maps.
Google Maps. Okay. Yes. Anything else?
Netflix?
Netflix. Oh yeah, like, does the algorithm work good to like suggest new things for you? I'm still on my parents' Netflix, but I don't want to get off because I've like trained the algorithm for like 6 years now, and I just don't want to start over. So yeah. Anything else?
YouTube?
Yep. YouTube. What's up? Or then up next? Anything not related to video? Get another category.
I've been playing with these chatbots.
Yeah.
There's one called Replica.
Mm-hmm.
It's got very publicized. Like last year already, it's supposed to learn about you and become your replica. And the promise is way beyond what is really. I've only been trying it for like a month. And there's another one called a VOE-bot, a VOE bot, which is quite nice. It's supposed to be a therapy chatbot, and the good thing about the design of that chatbot is that it prompts you. It's not an open-ended tree.
Oh,
So
okay, that's helpful.
It gives you options, and it primes you slowly into the conversation. So that's
Okay.
going much better. But
So
I
it's like
just
assisting you teaching it,
assisting
or
you,
guiding you teaching it?
yeah,
Okay,
to
that's
learn
cool.
about. So it's kind of guiding your responses, so it can learn
Okay.
more about you, but within its own narrow field.
Okay.
But I'm yet to see any AI-like or intelligence, or even very basic intelligence in either of these. But I've been
Yeah.
recently fooling with them.
Yeah, it'd be interesting to see like how long the learning curve for those is. But yeah.
You have to remember to use them every day. That's another
Oh.
thing with chatbots is there's no reason to use them all the time. And
Yeah.
they don't get that much data.
All right, you in the back.
It's very mechanical, but it's still syntax-based. Also correct?
Yes. And I notice whenever Apple like updates theirs, because all of a sudden I'm misspelling a word that I didn't misspell before, or they like think this word that I typed is suddenly another thing. So yeah, yes, that's an awesome one. All right. I'm sure you guys have like a million more because we're just like completely surrounded by AI all the time now, at least narrow AI. But let's move on to some other stuff. Okay. So all of that exciting conversation comes down to this. Machine learning blends ideas from statistics, computer science, and a bunch of other disciplines to design algorithms that process data, make predictions, and help make decisions. So it's a subset of AI, and so you'll hear about it from the perspective of like, oh, this is AI, and it is. It's just like one category of AI. It's like, this apple is a fruit. Yes, it is a fruit. There are other things that are also fruits, but yes, this is an example of a fruit. So yes. So there are, one specific, we kind of talked about it a little bit, going back to the general AI, the like WALL-E and Terminator. That general AI doesn't really exist today, and AI experts are really fiercely divided over how soon they think it's going to become a reality, because that's looking at like replicating an entire person's way of thinking and feeling and reasoning, whereas what we have today with narrow AI is just like, I can do this one task very, very well. I've been trained to do this one task. And maybe it's expanded to, okay, I can do these tasks very, very well. But anything outside of that, I don't know what to do. Or I think I know what to do, and the results are hilarious, which we will see in a couple slides, or more further down the deck. Okay. So there are 3 categories of machine learning. Supervised, which is where you give your algorithm a training data set, and you run it on it, and it says, okay, cool. I'm going to predict this is this, and this is not this, and this is this. And you're like, okay, that's wrong, that's wrong, that's wrong. This was right, so we'll keep you, and we'll reinforce, or we'll keep you going more in this direction by like, yes, those answers were correct, so keep going down that thought process. Unsupervised machine learning is more of like, hello robot, or hello computer, I have all this data and I don't even know where to begin with it. Can you please look at it and see if there are any patterns or associations or trends that I can't see with my human naked eye because there's just so much data here to look at. So it's like if you were, do you guys know the Where's Waldo books, or is that just an American thing? Okay, good. So it's like that, where you're just like, there's so much information here, it's going to take me forever, or I'm never going to possibly be able to find this, so I'm going to give it to a robot and they're going to be able to do it. Or like give it to a machine learning algorithm, process it through a computer, and it's going to be able to do it right away. Well, right away. And then the third type is reinforcement learning. So this is kind of like unsupervised, where it starts with maybe you pre-train it a little bit, maybe you just let it go on and start just discovering things on its own. But the thing with this is it maximizes a reward. So the things that maybe you've seen on like YouTube of I'm going to train this AI to play this classic video game, and it's just like fail, 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 fail at the beginning, and then like towards the end of the video it's just doing these like crazy things no one would have ever thought to do. So that's this reinforcement learning, where the reinforcement is don't die. Don't let your character die, or I'm looking for this high score type of thing. Yeah, okay. So I just threw like a ton of words at you guys. What out of all of that has been the most useful buzzword that you learned today? Or one that you're like, okay, cool, I learned something new, this is going to help me have a starting point to look into more stuff for my business, or this was just cool, I didn't know about this. Anybody want to volunteer anything? All of us knew all the words already, and I just wasted 15 minutes. No. Cool. Well, I hope that there were some in there that are giving you kind of more thoughts to chew on. All right. So now, actually, yeah.
Tell us a little bit more about unsupervised learning. So if there's no supervision, then what are we telling? How are we asking the algorithm to learn?
Yeah, so it's things like if you've got a very large just like a really dense scatter plot of data, and you're telling your algorithm, hey, look at this from a bunch of different angles and see if you discover anything interesting. And so this sort of machine learning isn't necessarily to have the machine make a decision for us. It's to have a machine show us things that we didn't see before or that we hadn't thought about before. And so it's to assist human intelligence instead of replace human intelligence. So maybe my machine learning algorithm looks at this, and I'm just like, it's just a blob. But maybe it goes through and it's like, oh, well, actually, you have this interesting, like, spiral pattern happening to your data, which I would have never been able to see. So, yeah, so this one is more for, like, kind of the idea of how, like, a microscope helps a biologist see more clearly into what's going on in like a bacterial colony. So, yeah, right. It's been about 45 minutes. Go ahead and take a 3-minute break, stretch, stand up. It's like a 2-hour session, which is just like I can't sit still for that long. So, but I get to walk around up here and you guys don't. So I'll see you in about 3 minutes. So we're going to kick off this next portion of talking about data analytics, statistics, studying data from the point of view of the scientific method. So as like a side note, your goal when you're looking at your data may not necessarily be to do an entire study. You may not actually care about predicting something or having a like concrete conclusion about something. Maybe you just want to explore your data and get an idea of what's in there. So in that case, some of these steps that we're going to talk about may not be as important to you, which is okay. But you do need to understand that if you're just kind of like looking at your data and getting a feeling for it, that's not the same. The like conclusions you draw with just your brain are not necessarily have the same weight as something that's gone through a rigorous statistical process. Because statistics, the outcomes for statistics can, in some ways, be contradictory to what we think is going to be the end result, and that's because we cannot get outside of bias that's built into our brains from our cultural context, from our life experiences. And so that's why we have statistics. That's why it's such a huge tool that's used across every industry in the world. So definitely okay to just like not be super rigorous when you're just trying to like figure out what's even in there or doing pre-research, as some people would say. But yeah, just understand that there's a difference between those two. All right. So the scientific method, if it's been a while, this is our refresher for it. First thing, we're going to define a question. Then we're going to gather information and observe, maybe. Or maybe we already have the information gathered. Make a hypothesis, which is an educated guess about the answer. Experiment and test that hypothesis, and then analyze the test results. Sweet, we're done. No. Then we're going to communicate what we found to other people. Because sometimes maybe like if you're just like playing around on your own, you don't really need to communicate, but most of you are looking at doing analytics in the context of business or your job, and then unfortunately we have to communicate with other humans. So, all right. Is that actually, yep. So the first thing, define the question. So, ask yourself right now, what is a business need? So we already thought about this a little bit. What is that business need that you were thinking about at the beginning of the session? Or like what is a question that you have that you want to answer with data? So kind of other ways to think about that if you're still not clear are what are we trying to do? What are we trying to measure? What are we trying to predict? Also, who is the intended audience for this? Is it a user, customer, decision maker for this thing that we're analyzing and the insight and prediction we want to give? Yeah, so as we're going through this section that's actually like talking about the actual analysis or statistical process, keep that business question or business motivation in the back of your head. Okay. So now we're going to go through a couple slides that talk about the different styles of questions. And so I've got styles of questions on this side, and then on the far side, I have some hints towards this is the type of analysis that you're going to want to Google later if this is the question you have. So the first thing, is this A or B? Is this an image of a cat or dog? Is this customer going to buy things or not? Is this A, B, or C? What mood is this tweet? Are they happy? Are they sad? Are they angry? Are they bored? Those sorts of things. All right. How much? How many? So how much will the rent cost in this neighborhood next year? How many Twitter followers am I going to get next week? Another thing, then this one's, is this weird? And this one is something that we care about a lot, like in the financial sector, specifically like credit card processing. Is this transaction fraudulent? Did this person really mean to spend $80 at a Starbucks in New York City? No. Is this out of the ordinary? Then we get into some kind of like combinations of some of those. So how likely is A versus B? Or what fraction of the results are going to be A, and what fractions of the results are going to be B? Not just is this A or B, but how is the whole pot divided? Also, how do A, B, C, D, blah, 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 blah. How do these all compare to each other? How are they related? So, for example, which fleet or van in my fleet of vans needs to have maintenance done on it first? Like, which one is the one that I have to spend the maintenance money on this month because otherwise the wheels are going to fall off and I won't be able to use it anymore, type of thing. Okay. And then, clustering. How is this data grouped, which was kind of like what I was showing over here. So for those Netflix fans out there, which viewers like the same types of things? And then also, one of the problems that we get, and depending on what type of statistical method or analysis method you're using, it can be hard if you have too many factors or too many parameters, A, B, C, D, AA, ZZ, continuing on forever and ever. And so one of the tools that we can use is called dimensionality reduction. And so that says, okay, I've got all this stuff. How many of these are really kind of actually the same thing? And I can just eliminate the duplicate information altogether or do something to combine them. So that's dimensionality reduction. So one of those is, what are the most common patterns in gasoline price changes across Finland? Or what groups of words tend to occur together in this set of documents? All right. So anybody want to volunteer their business question or their business need that they're looking at knowing more about analytics to solve? Go for it.
Anyone else wants to try? Anyways, I'd written down, I would like to know the profile of individual readers of my business blog.
Okay. Did any of those questions or tools match up yet? Maybe?
Depends on what data is available.
Yeah, that's a good point. What'd you say?
Yeah, I would say that maybe the fixed data
Mm.
would be
Something to help what you're working on? Mm-hmm. Anybody else have any insights to share? Yeah.
I have one HR related thing.
Sure.
More on machine learning and trying to identify the user pattern based on his LinkedIn profile.
Okay.
And based on his click, recommend him the most probable jobs for them.
Okay, cool. Have you played with machine learning before? Okay, good. That's going to be a really fun problem to tackle. Cool. All right. So it all goes down to the data. We can want to know everything in the world, but if we have no data to actually get us those answers, we're stuck. So take stock of your data sources. What do you actually have? So what data do you actually have right now? If you're a business, what data have you collected? Maybe it's customer data. Maybe it's if you're somewhere like Uber, maybe it's where all your drivers have been driving. So what data do you have that you own? Then what data could I collect? Maybe I can do a survey to my customers and see what they think. Maybe I can do some sort of experiment, like an A/B testing, where I give half my web users this website, and we give half the other web users this website, and we analyze how the behavior is different. Is there any open data that would be useful? The answer is probably yes, but there's a lot out there, so have fun digging through it. There's cool things out there, but there's a lot. Anyways. And then also kind of another thing, especially if you're a business and not necessarily an individual, is there data that I could purchase? Is there a data provider that has the data I want or I need? And instead of me going through the process of collecting it myself, can I just buy it from someone? All right. So now you have data. Now we get to talk about data quality. Because just because you have all this data and it's awesome doesn't mean it's actually useful at all. So it's like when you have guests coming over and you're like, yes, okay, I have spare bedding, I've got spare sheets, I've got spare pillows, but they're up way high in the cupboard. And you're like, cool. And you get up there and you're like, oh crap, these have actually been chewed to pieces by mice. So I thought that I had stuff for these people, but I don't. So it's kind of that sort of framework we need to work in. Like, what actually is there? It's not just, I know I have data, but what is it actually? Is it accurate and correct? Is it complete? Is it reliable? Are the formats standardized? Consistent, relevant, up-to-date? Are the records unique? So some kind of examples of this would be, you have customer records that are missing a zip code, or sorry, a postal code. Or maybe they have an address, but it's like not a real address. Maybe you have multiple representations of data. So maybe you have customers from all around Europe, and for some of them put in their country as FI, and some of them put it in as Finland. So we've got some inconsistencies here, where we would know, okay, those mean the same thing, but a machine's not necessarily going to know that. Also, do you have data that exists outside the reasonable ranges for it? Do you have a customer that purchased something in 2075? So things like that, or 1908, and you're a web application. So also things like currency. Do you have, like, is that really what you think someone meant to pay? Or do you think that's really what someone paid, or did they really mean to donate $1 million to your campaign or whatever? So being able to go through and make sure things actually make sense. So then the next thing is data cleaning. And this is the very unfortunate reality of doing analytics and data science, is you're like, yeah, I'm going to like learn cool things. I've got like this business question. I'm excited to like answer these things for these people that need to know this. And I've got some cool data sources from all over the place, and it's going to be awesome what I'm going to pull out of it. And then I'm just going to, yep, I got data sources. That's cool. So now I'm going to start talking about, okay, I'm going to do all these cool like analytics techniques. And then you're just like, oh, but my data is not going to go into my cool analysis tools. This sucks. So it always seems to catch people off guard, like how much time, or the fact, like how much time you may end up having to do with making sure your data is in the right formats and is complete and stuff like that. So some things to kind of keep in mind with data cleaning is identify and remove your duplicates. So if you've got duplicate entries for something that's like the same data in 2 lines, standardize your decimal places. So like for a value, are you going to have 2 zeros after your decimal, or are you going to have 3? So make sure that's the same, because that could throw off calculations. Especially if you're over in like the realm, maybe not in business so much, but like business, because like when you're working with financials, you want to know exactly how many places you're rounding, especially if it's something money oriented. And then things like dates and times can be in a lot of different formats. So make sure those are all matching across all your stuff. Plan how you're going to work around casing inconsistencies. So are you just going to or are you going to work with a tool that doesn't care if you've got capital letters and lowercase letters? Or are you going to go through and run an algorithm to put them all caps, something, or like translate your data to all caps, stuff like that. Normalize spellings. Make sure, so if some people are spelling things the British way and some the American way, like just thinking in English. And then have a plan for dealing with missing data. And this one it's just one little bullet point, but it's like, it should have just been like, missing data, what do I do? Because you have to be very careful with this. And there are a lot of techniques out there to be able to work through this. And in the notes on this slide, I have a link to an article that's like, okay, here, what are some things that I can do if I'm missing data? So we're not going to dive too deep into that today, but just be aware that if you have missing data, tread carefully, because filling it in, really have a good idea of what you're doing if you're filling in for missing values. because sometimes the missing value in and of itself may have meaning. But that's, I mean, it depends a lot on the context of your data and the question you're seeking to answer. All right. Cool. So now we're going to talk about making a hypothesis. So in the realm of like science and academic research, and maybe even if you're doing like a very thorough study for a client or for your own business, you need to have a clear picture of what it is you're researching. So it needs to be an educated, testable prediction about what will happen or what has happened. It needs to be written in clear and simple language, and the variables have to be defined in easy-to-measure terms. The point with this hypothesis that's guiding your specific research is that it needs to be succinct, yet it needs to convey exactly what you're looking for in order to eliminate confusion. All right. So then we get into this fun little thing. A research hypothesis that we just talked about is not the same thing necessarily. Well, it is not the same thing as a statistical hypothesis. In some cases, they may kind of overlap, and one serve the purpose to answering the other. But specifically, a research hypothesis is what the experimenter or researcher believes will happen in their research study. Getting into statistical hypotheses, the choice of the statistical test that you're using will depend, or the choice, so your hypothesis will depend on what type of statistical test you're using. And that will be determined by how you set up your research. So maybe you're caring about correlation. Maybe you want to compare means. Maybe you're wanting to do a regression line to predict the future. Maybe it's something as fun as non-parametric. There's like a lot of ways we could poke at our data to be able to answer this scientific hypothesis. So in order to answer this research hypothesis, this side of the board, we may end up doing a lot of different statistical tests. And so each of those tests are going to have something different, or have different hypotheses associated with them, statistical. So most statistical tests use these two statistical hypotheses that we're going to talk about. But they indicate something different depending on the test. So in general, the null hypothesis signifies the sample observations resulting purely from chance. So because we are spending time and maybe money on this research project, we are wanting to reject that what we're researching is only due to chance. So the alternative hypothesis, no, maybe you might have something that's like H1, H2, depending on what type of method you're using. The alternative hypothesis signifies what you observed is not chance. And statistics has a very weird way, I don't know, they're just like, I think statisticians are just very cynical or something because they're just really, really trying to reject this. They're just like, nah, I'm not going to accept anything. It's like, I will fail to reject this. So you never accept the alternative hypothesis, you just fail to reject the chance one. So it's one of my favorite things. Yeah.
Even try to ask a question is kind of loopy. To take an example, could you walk us through an example?
Yes. So we have, all right. Let's say I have a coin, and I'm going to flip it, and I'm going to flip it a lot of times, like 100 times, let's say. And if it is a fair coin, meaning that it isn't weighted on one side or the other, it's going to land heads up half the time, and tails up half the time. So my well, I guess these are actually. So in this case, I want to say that, so I'm trying to prove that this coin is not fair. So if it was completely due to chance, I would say the proportion or fraction of the time that it's heads versus tails, or the fraction of the times that it's heads is equal to 1/2, or 1/2. But I'm playing whatever game with my Uncle Steve, and he cheats a lot, and so I'm really sure that this is not a fair coin. So what I'm actually trying to prove that his head streak is not actually due to chance. It's because he's a cheater. So this is the one that I'm trying. Yeah. So we're through this, it would be like, okay, I'm doing this, and if I get like 50 heads, 50 tails, or something pretty close to that, then I'm going to say, okay, well, I failed to reject the null hypothesis. Okay, Uncle Steve, maybe what you've been getting, that streak of heads you got a little while ago, maybe that was actually due to chance. Or if I actually reject this, I'm like, I told you, Uncle Steve, you're a cheater, and now I want my half of the candy back. So, real simple. Yeah?
Basically, it's like in the research hypothesis. Hypothesis null means that there is no connection between variables, and hypothesis A means that there is a relation. So it's similar.
Yeah. Well, that's probably using a statistical like it's probably that research hypothesis is very strongly tied with its statistical test. But yeah, so there are some cases where the like scientific research hypothesis doesn't necessarily mean the same thing, which is why I made the difference earlier, but there are some times when it does. So
every observation ends up having either a null or an alternative hypothesis?
No, this is more when I take the sum. So I flip it. I have 100. I'm going to flip this coin 100 times. And it's going to give me heads 50 times and tails 50 times in a perfect world. But maybe when I actually like did it, this was like 49 and this was 51. So we're saying this is approximately 1/2 or approximately 50%. And so it's for specifically this sort of a test, which is a proportion test, which is looking at how it's that kind of A versus B, like how many of my things are A, how many of my things are B. We're specifically looking at the totals of things, but there are other statistical tests that are more looking at like individual things. There's so many out there, and I will let you have the pleasure of looking them up later so we can carry on for some other things. All right. So where are we at? As I talked about a little bit earlier, kind of the next step would be an experiment. So we, on the like data gathering slide, we talked about maybe we're going to need to do an experiment. So this would be where you would do it. And so this is just a visualization of an A/B test, which I mentioned earlier, which is like you have a website and you want to test how this color scheme affects, like, do your customers like this color scheme versus this color scheme, something like that. Or do they respond better to the comment button being put in this part of the screen versus this part of the screen? So it's an isolated, we've decided to just test one change in 2 different ways and see which one people like better. But there's tons of other experiments you could do. This was just one quick thing I could put on the slide. All right. So after you do your experiment, you test your hypothesis. So we were talking about, so a little bit more about statistical hypotheses. And like, so the null and your alternative, these guys, have to be mutually exclusive, meaning that if something happens, falls into this category, it cannot also fall into this category. So we need to know that when we're looking at this result, we can be like, okay, we know that one didn't cause the other. We know that they're independent of each other. So you got your null and your alternative hypothesis all figured out. formulate your analysis plan. So which test statistics are you going to look at? Which ones do you care about? Are you caring about averages? Like what's the average price of a house in this neighborhood versus the average price of the house in this neighborhood? Do we care about proportions, which is how much of the time is my coin doing heads versus tails? And then there's other things like t-statistics and z-scores, which are more the traditional like statistical curve. Like where does this fit in your population? And I will let you guys play more with that on your own later. So basically, we're going to now analyze the data with whatever that test statistic plan we were working with and find the value of that test statistic. And then we're going to interpret the results and either reject this guy or not accept, fail to reject this guy. So that's statistics, kind of in a nutshell. It was very high level. Okay, and that's on purpose. I didn't want to get down too much into the weeds because I cannot teach you guys statistics in a 2-hour section and also talk about all these other things. So, so yes, here's analyzing your test results with the test statistics. So, all right, don't worry too much about that slide.
Oh, but we're getting this deck.
Yeah, you're getting the deck. Okay, so then the next thing that's about like analyzing your test results, it's not just, okay, did this fit in the correct acceptance zone of this normal data curve? You need to actually use your human brain a little bit too. So for instance, I know you guys can't see this, so it's like, that was surprisingly easy. How come the robotic uprising used spears and rocks instead of missiles and lasers? If you look at the historical data, the vast majority of battle winners used pre-modern weaponry. It says, thanks to machine learning algorithms, the robot apocalypse was short-lived. So, and then the other one that's been coming, like this has been around the internet the last couple years, and it just cracks me up, and I pretty much guarantee you it came out of machine learning training data sets, because it's the, is this a dog or a food item? So we, looking at this, we're like, duh, that's a muffin. Duh, that's a chihuahua, like, hello. But the computer doesn't know that. So we also need to look at the results that we're getting from the machine and be like, check it against reality. Be like, does this actually make sense? Or is this really crazy and it's going to, if I base my decision on this, am I going to do something really crazy? So, like eat a chihuahua. All right, so I just poured like a semester's worth of statistics at you in like half an hour. Yes. So do you have any questions on some of them? I may just be like, that's awesome. Write it down and look it up later. But do you have any questions about how all of that could relate to your business? I'm just going to, yes? Do you have any that you want to vocalize or share with the class? All right, I'm going to just assume that there's just a lot of information and people need to digest it a bit more. So that is fair, because that was a semester's worth of stats. All right. And on that note, there are resources in my list at the end that will, if you haven't, if that was all like new or it's been a long time since you've looked at any of that, there's some free classes for reviewing some of that if that's what you want to do. Yeah. Okay, so now we're going to get into the exciting part, analysis tools. So the tools I have here that I'm presenting are not an exhaustive list. They are a list of the things that I have found useful, that I like using, and then I padded it with like maybe a couple more that I found around. But yeah, if you find something cool and it's not on this list, I mean, maybe email it to me because I think those things are fun. But yeah, okay, so for analyzing your data, so that pulling the meaning out, running maybe some statistical analysis, if you are not a coder, if the thought of like coding into a terminal scares you to pieces, or you just like, I do not have enough time to do that in my life, then this would be a good free thing for you to look at. Google Sheets. So if you have Gmail, you're already signed up for it. So yeah, it's a free Microsoft Excel alternative too. So that's been one that's, Excel is something that is really, can be really used in the in business for doing like basic analytics, or like trying to do that first wave of pulling information out of data. So it supports a decent number of statistical functions and mathematical functions, and in the notes on this page, I have actually a link to the list of all the functions it has, and some description and like what the inputs are and what it's actually going to do for you. Minimal coding. And one thing that's really cool about the Google Suite is that it supports multiple people working on the same file. So if you're passing something back and forth with a coworker, this is a really nice way to do it. If you really care about who made what change and when, this one may not be so much for that. You might want to go through a more strict version control system. But if you're just actively collaborating together, especially if you're working remotely with someone, this is a really nice tool. And it's stored on the cloud, so you can access it from anywhere. It's mobile friendly. I even checked, on my phone, you can do statistical functions in your spreadsheets from your phone. So that's cool. Google Sheets. Okay. Next one, this was my first introduction to statistical software, and that's R. It's a free statistical software package. You download it. You can do it just from the command line if you really want to, but they also have some nice GUIs, graphical user interfaces. My favorite one is R Studio, so I don't have a screenshot of it, but it's got the terminal that you run things in, but then it's got code that you're can be writing a program and you can run the whole thing or just parts of it. It's got your visualization outputs, and then the help files for the different packages or libraries you're working with. It's pretty nice. So one thing that's really awesome about R, and why I'm very, very passionate about using it, is because it is very much supported and actively used by the scientific community. And so it's an open source software, and no matter what application you have that you're trying, or what business or science or some sort of question that you're trying to solve, there is a tool set out there already because somebody built it as part of their master's thesis, probably. And so there's a very wide range of packages or libraries or toolboxes or plugins, however you want to think of that you can download and to make R work for just your problem that you're trying to solve. And it has a very active open source community, especially with in the science world. So if you really want to be up to date with what the scientists in academia are using, then that would be it. Another thing that's kind of been up and coming over the last couple years for the field of data science, it used to be just R. We love R. But especially as we're moving into, it's not just enough to build a machine learning model or build a statistical analytics model. Have it run once, make a beautiful picture, put it in a report, tell people about it. We don't care. That's still very important, but another thing that's become even more and more important is being able to run those statistical and machine learning models live in your production environment of your web application. So one thing with Python has started to become much more popular it's gained a lot of popularity, and it may even have passed R now in the data science community. So this is a general purpose coding language that has statistical modules, packages, libraries. It has things that you can import that will do statistics for you. So this is a coding language. There are some nice things out there for, so you're not just coding in a terminal. My favorite is Jupyter Notebook. It used to be called IPython, but it's Jupyter Notebook now. And so this one, it's nice for you to be able to mix your notes about something, some code, see the output, see a visualization, all kind of in a format. So it's not, you wouldn't use the notebook for sending your algorithm to your production environment maybe, but it's nice for that initial research phase. But yes, good at productionalizing analytics models. A couple other things and why from the computer science side that we're excited about this is it integrates really well with most cloud platforms or platform as a service providers. So that's where the future of websites and data hosting is now. It's also fast and scalable, and so you can do stuff like on your little laptop all the way up to Google uses Python, actually, so to run their stuff. Actually, they use Python plus something they built in-house called TensorFlow, which is also open source language for machine learning. Another cool thing about Python is it supports parallel computing. So you can, if you've got like a ton of data, you're not going to run your statistical or your machine learning process or algorithm on the whole thing at once. You're going to divide it up into smaller batches. Like if you have 1,000 cookies you need to bake for a wedding, you're not going to cook them all at once. You're going to cook them in batches. And so the thing with parallel computing is it's the difference between me cooking 1,000 cookies for a wedding in my little oven versus a professional bakery that has 10 ovens to cook cookies all at once. So you can do things at the same time. There we go. Python, that's my plug for that. So those were all for just doing the analysis. So doing statistical analysis, scientific analysis. If you're just worried about what do I even have in my data, that's going to be data visualizations, which is going to be in a slide or two. So our last step in our scientific method is communicate your conclusions. So hopefully at the beginning you kind of thought about this as you were like designing the analytics process you were going to go through, but especially now, or maybe you did think about it at the beginning, but you've got multiple audiences that want to consume this. Maybe it's you're doing a report, but like your not very technical boss wants to see it, but then also your very technical development team wants to see it too. So you have to think like, okay, how am I going to predict? I've done this analysis, I've gathered this information, I've figured out these insights. How am I going to portray it in a way that actually is meaningful to the person receiving the information? So identify your target audience or audiences. Remember what you're trying to achieve. This is a big one, because we get into the weeds of doing analytics and we're like, oh, this is cool. Oh, this is cool. Oh, this is cool. And you can just kind of lose your focus. And so when you get to the end, yeah, it's fine that maybe you did all of that extra research, but what did you start out with wanting to know? I love this. Avoid creating a wall of text, as I have created a wall of text on this slide. Sorry, guys. And then to add to that, use visuals to convey information and add interest. The most boring thing in the world for anyone is to just it's so hard for people to just read a textbook over just walls and walls of text and teeny tiny type, and your eyes lose the spot on the page, you end up rereading the same sentence 3 times, and it's just so dense that it's hard. When you get done with reading a chapter in a textbook, you're just like, what was that even about? What did I even learn? So use visuals to break up your walls of text, and then also, don't go so far the other way where it's just visuals, because if you have just visuals and no context, they're also meaningless. So they look pretty, people are impressed, but they have no idea what you're trying to say. And then kind of the last thing, link the information that you found back to your business need or your research question. So it doesn't matter if you found cool things if they don't actually tell you anything about the question you were trying to answer to begin with. So visualization tools. So if you are a coder or you want to start playing with coding, R and Python have actually a lot of different data visualization libraries. These are just kind of the 2 go-to ones. And the cool thing about data visualizations that come from a coding standpoint is you can make it be anything you want. You can change what color, what symbol, you can make it animated, you can leave it static so it can be pretty in a PDF report. If you just had a scatter plot but you wanted to put a line through it, you can put that line through it. So it's very, very, very flexible. But with the flexibility comes a steeper learning curve, potentially. So on that note, I also have some that are visualization tools that do not require coding. Yay! So these are also nice even if you are a coder and you just want to like throw something together real quick and you don't want to spend the time to build a graph that looks super cool. They already have pre-made ones. So within Google Sheets, they've got built-in ones that you can use. And they actually have a pretty decent-sized library. The last time I had looked at it was probably about like 5-6 years ago, like into my undergrad. And I was like, oh, there's not really anything here. But I checked like this week, and I was like, oh my gosh, there's actually some. So I'm excited to tell you guys that is a great resource for you. And then 2 things that I found crawling around the web this week are Web Data Rocks and Chart Builder. So Web Data Rocks is a bit more flexible. You can have a lot more types of visualizations that come out of it. You import a CSV Excel type file, and then it'll let you use a user interface, a mouse, to pick things. No coding required. Chart Builder, this one was developed by, I can't remember. It was a newspaper in the States that they needed something that their reporters could very quickly dump their data into and get a visualization out that they could use in their articles. And so this one is like super easy. You just paste your data in this box and then pick a couple things for how you want it to look. And then it gives you a data visualization that works for websites, and it also has a little picture of a phone so you can see how it would look on a phone screen. That is very simple, but if that's all you need, that's awesome. So yeah, there's some visualization tools for those that don't really want to deal with coding. All right, so just to recap, this is what we talked about. We went through the scientific method. We defined our question that was relevant to our business. We gathered our information and observations. Maybe we did an experiment. Maybe we just looked through the data that we already had available to us. Then we made a hypothesis. Oh, wait, sorry. I skipped it. So we gathered our information, and before we could really go into doing analytics, we cleaned our data, because that's what we need to do. Then we make an educated guess about what we think the outcome is going to be, which can be a research hypothesis, which could also overlap with what your statistical hypothesis is going to be if you're just doing one test. But if we have multiple statistical tests that we're going to do, we're also going to have statistical hypotheses for each of those tests. Experiment. So if we needed to do an experiment, this would be where we would do it. Test our hypothesis against the results, and so that's the actual doing the analytics, running the analytics algorithm part. Analyze your test results. Do they make sense? Are they significant? Are they not? And then communicate your conclusion. So before I get into actually talking through these last couple minutes about types of resources that I found useful, do you guys have any questions or like, that was cool, I'm going to use that for my business moments or anything like that today that we haven't already talked about? Are we thoroughly confused on statistical hypotheses? Okay, I'm going to take that as a yes, no. All right, so self-study resources. So the first one is just like helpful articles that have helped me find guidance, like when I'm trying to put together a data science project, or I'm trying to answer a question for my business or for myself or for school. These have been really helpful for me to help understand what tools do I have out there, how do I phrase my question, what techniques, what types of things can analytics, machine learning, statistics, what types of things can they answer, what things maybe can they not. Also, just a plug, check out the notes that are on each slides. I have plenty more links on them. But yeah, so the purpose of this slide is just to give you more context if you want more context. So then we're going to go on to YouTube. And so this is not an exhaustive list. By far, there's so much stuff on YouTube. One of the biggest uses of YouTube, all of those like different softwares that I talked about, like Google Charts or Matplotlib or whatever, you can go onto YouTube and be like, what is this? Show me a demo. How do I do this? And there'll be somebody walking you through it. So for you guys that are more audio visual learners, this is going to be where you want to go to learn more. So specifically these three guys are YouTube channels that I've really liked how they explain things. They have some stuff about statistics, they have some stuff about machine learning, some stuff about math, some stuff about random other stuff too. But they explain things really well with really interesting graphics that make things make sense quickly and are also entertaining. So I like them a lot. And then MOOCs. So those of you that like to learn by doing or want a more in-depth understanding of this, and we will be sending this out, so don't feel like you have to write down all of them. My favorite has been Coursera, and both Coursera and several of the other of the MOOCs that are on here, they are, for me, studying on my own can be very hard to stay on top of myself, to be like, okay, I need to go home after I worked a full-time job and open my laptop and study for this amount of time. That's really hard if I don't actually have motivation or accountability. And so what Coursera does specifically is they're set up like a class. And so you have assignments due at a certain time. You have a test due at a certain time. The class has a start period or like a start time, not each session, but like the beginning of the course and an end of a course. So you have very much like, I have 2 months to finish this. And it is flexible, so if you weren't able to finish it all, they will let you like port your data over to the next session. So it's not like, oh, I've lost it, I have to start all over again. But for me, that accountability is really nice. There's also on some of the others, which might be in the longer list of MOOCs, which I have on the next slide, or not on the next slide. Oh, here's another one, Udemy, which is kind of the similar thing. Both Coursera and Udemy now have paid versions, but that's like if you want a certificate to be able to put on your LinkedIn page or include with a portfolio or give to your employer type of thing. But they, at least for Coursera, so Udemy has classes that are free and classes that are paid. But Coursera has pretty much everything that's paid you can take free, almost. They now have some like master's degrees on there, which I'm not sure if you can. But like their specialization tracks, you can take it all for free and you just don't get the like certificate at the end. So Udemy, there's some things for Udemy. I haven't worked with Udemy as much, or Udemy. I actually don't even know which one it is. But I've done a little, but not as much as with Coursera. Okay, so here's others. There are so many massive open online courses and platforms. And here are just like a couple more that are like in English. So we've got edX, FutureLearn, which is out of the UK. Udacity, so both edX and Udacity are American. Canvas is American. Stanford Languida is American. Swayam is actually out of India, but it's in English. And then I've included down here in the notes, which you can't see, a link that has just like a ton of MOOC providers and MOOC platforms. And they have, if English isn't your favorite language to learn in, or if you speak other languages, they also have things like Mandarin, Spanish, Portuguese, French, Italian, Thai, Hindi, Arabic, German, just like it's a huge list. So there are so many of these out here. You will definitely be able to find one that fits your learning style and like your language preferences and stuff like that. Oh, another thing, I plugged that Coursera is really awesome if you want deadlines, but there are also MOOC providers that don't have those deadlines, and they're just like, here's basically the content for Calculus 1 class, and here's the chapters you'll read out of a textbook, and maybe here's a pre-recorded lecture, and here's an assignment, and then I have a sheet that you can check your answers against, but nobody's checking if you did it. There's no grades, no pressure, so you can do it whenever you want without feeling like, oh no, I'm not doing it enough. So that's really awesome too. Okay. Oh yes, and the most important tool that I want you guys to take out of this, let's see if this works. Google, yay. That website was Let Me Google That For You, if you are curious. But yeah, so the biggest tool that you have now is Google, because it is so much information about the world. And hopefully, through this talk, you have been able to think or absorb some of these concepts, maybe take some notes that you can be like, okay, I know where to start asking questions now. I have a little bit better idea of an intelligent question to ask Google to be able to learn more about this thing in the future. So, do I have another slide? I might not. That might be it. All right, so back to my Communications 101 presentation, professor. Tell them what you told them. So we talked about buzzwords. We talked about types of data storage, types of analytics. Then we went through the scientific method as it relates to an analytics project. And we got some ideas of how can we answer our business question in a rigorous statistical scientific way. And then we talked about some self-study resources. And hopefully that will give you guys some exciting new adventures with data analytics in the future. So, thank you for coming today. And before I go, oh man, it's 5:44. Yes! Because I didn't time my slides and I was worried I was going to end up with either 30 minutes or 4 hours. So we're good. We're right on the dot. Okay, so while I'm still here, before I go, does anybody have any more questions related to all of this information? All right. Feel free to come up and chat with me on your own. You are released. Have a wonderful Monday evening. Thank you.
Thanks so much for everyone, and also thanks Jessica so much. I know that today we have a lot of new information, and don't worry, we will have more sections coming up in this week, which is focusing on SQL. That's also Jessica mentioned earlier, and also use data for decision making. So if you are more interested in data analysis, you can participate in those sections, and the SQL will start tomorrow.